All right, so we are going to use some of our knowledge of trigonometry to keep track of the angles along the x-axis. So I have a chart or a table on the right side, and it has all of my angles in degrees, and it's all of the angles that are on the quadrants, so the 0, 90, 180, 270, 360, and it's also all of the 30, 60, 90, and 45, 45, 90 angles all the way around to 360. So it's all of the trigonometric values that we can actually do by hand, but we're going to use a shortcut and use our calculators to make our life a little bit easier because we want these in decimals anyway. So what you need to do is take your calculator, and you want to make sure that you're in degree mode. So in order to do that, you're going to press the mode button, which is right next to the blue second button. And it's going to bring up the screen that you can see a portion of. And you need to arrow down until you see this row right here where it says radian and degree. And you want to make sure that you are in degree mode. So if radian is highlighted, you need to arrow to the right and then press enter so that degree is highlighted. Once you have degree highlighted, you can press clear or you can press second mode, and that will get you back to the regular calculator screen. So now from here, what you're going to do is you're going to just type in whatever the angle is. You're going to type in the sine of whatever that is, and it's going to give you a number, and that's going to be your y value. So if you type in the sine of 0, it's going to give you 0. If you type in the sine of 30, it's going to give you 0.5. And then I have an example down here. If you type in the sine of 45, it's going to give you this crazy long decimal. So I'm just going to say 0.707. We don't need the whole crazy thing. We just need enough to kind of get an idea of where it needs to be. So I'm going to go ahead and just fill in all of these values. These are things that you should be able to just type pretty easily into your calculator. It's more tedious than it is difficult. So sine of 60 is 0.866. Sine of 90 is 1. And then we have 0.866 again, 135, 0.707, 150, 0.5, 0, and then our numbers start to go negative. Negative 0.5, negative 0.707, negative 0.866, negative 1 at 270, negative 0.866 at 300. So you'll notice that a lot of these numbers are repeats. They're the same numbers happening over and over again, and that is not a coincidence. Some of them are positive, some of them are negative. Now what we're going to do is I'm going to take these numbers and I'm going to plot them. Now our angle is going to represent our x value. So when we graph these, when we actually start doing these by hand, we're going to be doing them in radians and not degrees. But this is going to be our x-axis, or our theta is what it's going to actually represent. And then if you look at our y values, which is all the values of sine, those are all between -1 and +1. So if you look here, this is my max at +1, and then this is my minimum at -1. It never goes beyond those two numbers. So I'm going to label my y-axis. The highest it needs to go is 1, and the lowest it needs to go is -1. And then along my x-axis, I'm going to label all of my main, all of these angles. So the last one is 360, and then halfway is 180, and then this is 90 and 270. And then I've got 45, 30, and 60. So each of these is going to be broken up into 3. Okay, so I'm not going to label every single one of them because we're just going to go in order. Now, when I graph these, I'm going to have to do some estimating because I have a lot of decimals, but that's okay. So my first point is 0, 0. At 30, I'm at half, so that would be about here, because this would be about 0.5. And then I'm at my next one, 45, I'm at about 0.7, so that's here. Then I'm at 0.8, which is almost to 1. And then at 90, I actually am at 1. And now I kind of go back down and pretty much the same order, just reverse. that's my first one, and then I'm back down here at 0.707, and then I'm back at 0.5, and then at 180, I'm back down to 0. Okay, and now my numbers are the same, I'm just going negative. So at 210, which is this one right here, I'm at negative 0.5, so that would be about here. So negative 0.5. And then I'm at negative 0.7, negative 0.8, and at 270, I'm all the way at negative 1, and now I'm kind of going backwards again. That's my negative 0.8, negative 0.7, negative 0.5, and then at 360, we're all the way back to 0. So what we just did here is we graphed a sine curve. If I now connect the dots as best that I can, this represents one cycle of the sine curve. So now let's talk about some of the default values for sine. The domain, meaning how far the graph can stretch left and right, is actually all real numbers. It can go on forever and ever, but for the most part, we're going to choose to limit our domain between 0 and 2 pi. Most of the time we can figure out everything we need to know, or you're going to be asked to graph one cycle or one period of the graph. Most of the time that's going to be between 0 and 2 pi. That's what you see here on this graph that's kind of highlighted in blue. The range of our standard sine graph is always going to be from 1 to negative 1. 1 is going to always be the maximum value for your y's, and negative 1 will be the minimum value. The way we're going to write that, we're going to write it in brackets because we are including the values. If we were not including negative 1 and 1 in our values, we would use parentheses. But since the function can actually take on the value 1 and it can actually take on the value negative 1, we'll write it like this, kind of like an ordered pair. The amplitude of your standard sine graph is talking about from the midline of your graph, how far up and down you can go. If you look at this graph over here, you can see that the highest point that it gets to is 1, and the lowest point that it gets to is negative 1. So those are both 1 away from the middle of your graph. So the amplitude is 1. That looks like a negative. It's actually just a 1. And then the period is 2 pi, meaning you start at 0 and you stop at 2 pi. And then last but not least is the midline. For this standard graph, the midline is going to be at 0, y equals 0. So you can kind of see it here. It would be this line that cuts right in the middle of the top and the bottom sides of your sine graph. Now, in this bottom box here, you can see this is the standard sine graph. That's like your parent function. And then the y equals a sine b x minus h plus k, that is like where all the transformations are happening. So I just want to go through really quick what all these transformations mean. The a is your vertical stretch or shrink. That's the number that tells you your amplitude. And it can also be negative. If it's negative, that would mean your graph is reflected. But this vertical stretch shrink stuff, that's the amplitude. Your amplitude is always going to be a positive number. The negative there would only represent a reflection. It has nothing to do with the amplitude. All right, this b that you see here, this number affects the horizontal stretch of your graph. And that is what determines the number of cycles between 0 and 2 pi. So what that's really going to affect is the period of your graph. All right, now this h and k stuff is hopefully familiar to you. H is a horizontal shift. And we actually call it a phase shift in trigonometry. So it is horizontal, but you're going to see it referred to as a phase shift. And remember that it's opposite. So if you have a negative, it's actually going to move the graph to the right. If you have a positive, it's actually going to shift the graph to the left. And then this last thing that you see is the k value. K is your vertical vertical shift. And that's going to tell you up or down, so positive for up, negative for down. And this is also going to tell you your midline. So your midline is always going to be y equals k. So these next examples ask us to find the midline and amplitude of each sine function. So just a quick reminder, you have your basic function, which looks like this. And the numbers that we're going to be focusing in on for midline is your k number. So your midline is always going to be y equals k. And then your a number is going to represent your amplitude. And it's only a positive number as your amplitude. The negative would represent if you had a reflection. So we're basically going to take the absolute value of that, whatever that number is. So let's do midline first. We'll just go through all three of them and do midline. So for number 1, there is no k value. It would be like there's an invisible plus 0. So that would mean your midline would be y equals 0. For number 2, you have a k number, which is positive 3. So your midline would be y equals 3. And then for number 3, your k value is negative 5. So your midline would be y equals negative 5. Now for amplitude, we're looking at the number that's in front of sine. So for amplitude for number 1, the number we're focusing in on here is 2. So the amplitude for number 1 would be 2. For number 2, it's like an invisible 1 here. It's a negative 1. Remember that the negative does not affect the amplitude. So since the amplitude, since the number here is just 1, your amplitude would be 1, which really means it's not changing from your parent function. And then for number 3, your a value, which represents amplitude, is 1/2. So in number 1, this would represent a stretch, meaning that your graph is going to be twice as high as the parent function. And then in number 3, this would represent a shrink, which would mean that it's going to be, it's not going to be as tall. It's going to be shorter than your parent function. So again, I just want to remind you of that function, that equation that you saw a few slides ago. So what we're going to be doing is taking information and plugging it in and writing the equation that represents this information. So let's start with number 1. It says that the amplitude is 4. Amplitude gets plugged in for A. And since that is the only thing that is getting plugged in, we're not going to have a B value, an H value, or a K value. So your equation is going to look like this. Your A and then sine x. So for sine x, we don't have any other transformations, so we are done. For number 2, we have a midline of 1. Remember that your midline number is telling you what your k number is, and then reflected tells you that you're going to have a negative in front of sine. So I know that I'm going to have a negative. There's no a value, so I'm just going to write negative sine x. And then I'm going to write my plus 1 for my midline, which is my k value. For the last one, number 3, we have an amplitude of 1/2, so that's our a value. Midline is 1, that would be your k value, sorry, negative 1. And then it's also reflected, which means that we're going to have a negative. So we're going to have a 1/2 in front, and it's also going to be negative since it's reflected. So we're going to have negative 1/2 sine of x. And then the midline is negative 1, so we're going to have minus 1. First thing we're going to do here is find the midline and amplitude, and then we're going to use that to write the equation of a function. So to find the midline, we're going to identify the highest and lowest y values. So my highest y value is at 4. My lowest y value is at negative 1. So for the midline, I'm going to use that little formula. And remember, it's always going to be y equals, and then it's your highest value plus your lowest value over 2. So that would be 3 over 2 or 1/2. I'm sorry, 1.5. So your midline would be y equals 1.5. And then amplitude, it's almost the same formula, but it's going to be 4 minus negative 1 over 2. So that would be 5 over 2 or 2.5. Okay, now recall that midline gives you your k value, and amplitude gives you your a value. So when we write our equation, it's going to look like this. Y equals 2.5 sine x, and then plus our midline value, which is plus 1.5. All right, next equation, or next graph here. For our midline, we need to find our highest and lowest y values. So I have -2 and then -4. Those are my extremes. So for the midline, we would have y equals -2 plus -4 over 2, which is -6 over 2 or -3. So our midline is y equals -3. And then for amplitude, almost the same thing. We're going to have -2 minus -4 over 2, which is 2 over 2 or 1. So our amplitude is 1. And then one other thing to notice is if you look at the graph, so if we say this is our starting point, as we usually do, right on x equals 0, usually the graph goes up first and then goes down. So since this graph goes down and then up, this is a hint that this graph is also reflected. So we've got some information here. The midline tells us our k value, amplitude tells us our a, and then the fact that it's reflected means that my a value should be negative. So my equation is going to be y equals negative, and since the a value is 1, I don't have to write it. I can just do negative sine x and then -3. All right, last example of this type. We have to find midline and amplitude. Midline is, we have to use our highest and lowest y values, so that would be 6 and 2. So for midline, I would have 6 plus 2 over 2, which is 8 over 2 or 4. So remember it's y equals. So midline is y equals 4. Amplitude, I'm going to have 6 minus 2 over 2, which is 4 over 2. So the amplitude is 2. And then again, we should check to see if it is reflected. This one is reflected. If you take a look here, this is our starting point where x is 0. Usually the graph goes up first and then down, and this graph goes down first. So this is reflected. So then this gives us our k value, our a value, and then this tells me a should be negative. So my final equation would be -2 sine x and then +4 for the midline. Now we're actually going to be graphing one cycle, which means one period of the graph. Up to this point, right now, one period means from 0 to 2 pi. So the equation we're dealing with is y equals 3 sine x. So the first thing that sticks out to me is this 3. This is my a value, and this is telling me that my amplitude is 3. So what that means is instead of my graph going up to 1 and down to -1, it's going to go up to +3 and down to -3. So the first thing I'm going to do is label on my y-axis my highest and lowest numbers that I can determine because of the amplitude, which is that a number. Now on your x-axis, you're always going to want to have the same numbers, and they are all the quadrantal angles. So you always want to have pi over 2, pi, 3 pi over 2, and 2 pi. And those are going to be pretty standard until we start shifting things around and changing the period. But for today, those are going to be the standard. So now, usually, and I'm going to draw a little chart up here. These are numbers that you want to have memorized. These are the numbers for your parent function. So 0, pi over 2, 3 pi over 2, and 2 pi. Those are going to be all of your x values. And then your y values go 0, 1, 0, -1, 0. And these are numbers you should have memorized. So I'm going to do those in orange. So 0, 1, 0, -1, and then back to 0. So this orange line right here, this represents the parent function. And what I'm doing is a function that is 3 times higher and 3 times lower. So I'm going to do that one in blue. So 0 times 3 is still 0. If I go 3 times higher than 1, that would be up to 3. Back to 0. 3 times lower would be at -3, and then back to 0. So now I'm going to connect the dots. So now that blue line represents this equation right here. And you can see that it is 3 times higher and 3 times lower. Now for the zeros, that's asking you where the graph crosses the x-axis. And I can see 3 times when it does that. Once here at 0, 0. Once here at pi 0. And then again here at 2 pi 0. The domain that we are talking about goes from 0 to 2 pi. And we are including 0 and 2 pi in our domain. And then our range is talking about all the y values that this function takes on, which would be from the lowest point would be at -3, and the highest point would be at +3. This graph doesn't have an amplitude change, but rather it has a vertical change. So this is going to be the same as our parent function, but it's going to be shifted down 3 units because of this -3. Okay, so what I want to do first, I'm going to label my x-axis using my standard x values, pi over 2, pi, 3 pi over 2, and 2 pi. And then normally our graph goes from +1 to -1. It fluctuates between those two y values. So what I'm going to do in red is draw our standard parent function. So 0, 1, 0, -1, and 0. So I'm going to draw that in kind of light. So this is what our regular graph looks like. The graph that I want to draw is going to be shifted down 3 units. So instead of starting at 0, I'm going to add, so this is going to be -2, -3, -4. Instead of starting at 0, it's going to be starting at -3. And then all of these points are going to get shifted down 3 units. So instead of going up here at 1, it's going to be here at -2, then back to back to -3, down to -4, back to -3. So this blue line is actually going to be the graph that we would consider the answer for this problem. Okay, now the period of this graph, this is asking how long, what's the length of one cycle, one of those patterns, and that is between 0 and 2 pi, which is actually going to be the case for all of these problems today. So the period is 2 pi. The midline, you can look at your graph and you can figure out your highest and lowest values. I think the easiest thing to do would be to look at your k value. That tells you your midline. So our midline is y equals -3, and you can actually draw it in, and you can see that that actually does look right because our graph goes just as high above that midline as it does below. And then the amplitude would be 1. You can look at the graph and you can just see that the amplitude is 1 because it's 1 away from the green line at the highest and lowest points. Or you can take your highest and lowest numbers and subtract them. So if I did -2 minus -4 over 2, you would get 2 over 2, which is also 1. So either way, you end up getting the same answer. This has 2 things going on. Number one, it's reflected because I have a negative in front. And then I also have a vertical shrink because of this 1/2. So what that means is that my amplitude is 1/2. So instead of my parent function, which goes up to 1 and goes down to -1, it's going to go up to 1/2 and down to -1/2. So the first thing I'm going to do is draw in my standard parent function because I think it's good to compare. So my standard sine function will go 0, 1, 0, -1, 0. Okay, now this one that I'm going to do in blue, 2 things are happening. Remember, it's reflected. So instead of going up first, we're going to go down first. And then it's instead of going up to 1 and down to -1, we're going to go to 1/2 and -1/2. So my first point is still going to be 0. Now I'm going to go down to -1/2, so -0.5, back to 0, up to 1/2, and then back to 0. So this blue graph will actually represent this problem here, and then the red graph represents the parent function. So now it asks us what the period is, which is the length that it takes to complete a full cycle, which in this problem is 2 pi. The midline, there's a couple different ways you can see this. Number one, I didn't have any k number here, so I know that it's 0. You can also look at the graph and see that it's centered on the x-axis, which is the line y equals 0. And then the amplitude would be your a number. And remember that this negative does not affect amplitude. Amplitude is always going to be a positive number, so it's going to be 1/2. All right, last one. There are 3 things happening in this problem. The first is that you have a reflection. We also have a vertical stretch, which means that the amplitude is going to be 2. And then lastly, we have a vertical shift. So that's going to move that midline up to +1. So the first thing I'm going to do is my standard function. Which usually goes up to 1 and down to -1. So that would be 0, 1, 0, -1, and 0. So here's my standard function. That's like the parent. And then in blue, I'm going to do the actual equation for number 4. So lots of things are going on here. Everything's getting moved up 1, so I'm going to add another tick mark on my y-axis. I'm also going to go down instead of up first, and then I'm actually going to be going twice as high and twice as low. So I'm actually going to need quite a bit of extra stuff here. Okay, so my first point is at 0, but it's going to get shifted up 1, so it's going to be right here. My next point is going to go, the amplitude is 2, so I have to go down 2, but I'm sorry, I'm going to go 2, but I'm actually going to go down because it's reflected. So at pi/2, I'm going to go down all the way to -1, so that there's 2 units in between those 2 points vertically. Now I'm going to go back to my midline, which is at 1. Now I have to stretch up 2 more, so I'm actually up to 3, and then back down to my midline, which is at 1. So here is my new function in blue. Okay, so now it's asking me for maximums and minimums. There's only one of each. This is the maximum right here, and it's at the point 3 pi/2 and then 3. And then I have a minimum here. I didn't write that this is a max. I have a minimum here, which is at pi/2 -1.